422?
0.52.
0.52, okay. 52 what? 520. So we can say 52% of the people in this court were either guilty or did it. That's what we can say for this. You okay with this so far? You sure? All right. The reason why we did this example, I honestly need you to be okay with this before I go any further. So if there's any questions, now's the time, guys. We have some time. So now's the time. Not sure if you are all right with it. Good, fine. Yeah. Right. This was the big deal, that double count. Because when you have non-mutually exclusive events, this will happen every time. In order to get rid of that double count, we have something that's called the addition rule. So the probability of A or B, we require some elimination of the double count. Requires elimination of any double count. You ever watch Sesame Street? You ever see the count? What's his name? Is it just the count?
Yeah.
1, ho, 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 ho. If he was a double count, he'd go 1, ho, ho. That'd be lame. Because he did it twice, right? We don't want to do that. You sound ridiculous on Sesame Street. You don't want to sound ridiculous on Sesame Street, do you? Do you? No, of course not. You want to sound like a genius, like the count. You can always count. So this requires any elimination of a double count, this idea right here. So when we're looking at the probability of A or B, it seems very easy at first because like, well look, all I'm going to do is add the people who are guilty plus the people who did it. So we'd say, sure, that will work just fine. Probability of A plus the probability of B. That will actually work great for anything that is mutually exclusive. I hope you're listening right there. This will work just fine for anything that is mutually exclusive. For instance, if you want to find the probability of rolling, like in our last example up here, a 1 or a 5, a 1 or a 5, all you'd have to do is say, oh, what's the probability of rolling a 1? That's 1/6. What's the probability of rolling a 5? Not 5/6. 1/6. There's one choice to make a 5. There's six sides. So you'd say, oh yeah, probability of rolling, I hope this makes sense to you. Probability of rolling a 1 or a 5 is 2/6. Right? You have a 1 or a 5. There's 6 choices. You have 2 of them are the right one. So that means there's a 2/6 chance of that. This works great for mutually exclusive events. If I have something that's not mutually exclusive in this case, what's going to happen here is if you add guilties plus did-its, you're going to get this case right here. And what I've crossed out is the double count. Here's my guilty. Here's my did-its. Notice how I have the same number twice. You with me? So in order to eliminate the double count, here's what you do. You add this one, event A, that's our guilties, to event B, that's our did-its, but then we minus the probability that they could occur together. And that's the probability of A and B. This right here is the probability of guilty and did it. Notice how what I'm doing here, I'm not eliminating this altogether. I'm eliminating the double count version of this. Do you see that? This one's going to, look at the board right now for me. This one's going to count it once. This one's going to count it twice. So 2 times. I'm taking it away 1 time. How many people understand the formula? That's why that's up there. So here's your event A, here's your event B, here's eliminating the double count. That's what this does. One note I need you to make before we get out of here. Please write down right now, because we are going to have another and later on, and it means something different. Right here on this and, this is in a single trial. Please write that down. Single trial. So last time we had just covered the addition rule and that was it. And we found out that if we want to find the probability of A or B occurring in a, was it a single trial or multiple trials, do you remember? It's a single time. It's like the probability of rolling a 3 or a 5 on a die, or a 1 or a 5 on a die in a single roll. If we want to find that probability, really it is addition. We take the probability of the first event occurring plus the probability of the second event occurring, and then we subtract something. Do you remember why we have to subtract something? You might get a double count. If you don't have mutually exclusive events, or we'll find this word out in just a second, called disjoint events. If you don't have that, then you are going to encounter some double count. So what this part does, that part eliminates the double count in this equation. Otherwise, you're going to count the same number twice. I think we saw this over here. Didn't we see this in this example? I asked for the people who were guilty or did it. The people who were guilty or did it are, this row is guilty. This column did it. But if I add this plus this, and then this plus this, I'm going to count that 72 twice, and I need to eliminate one of them. So this is what we do mathematically. Because if I really look at this, if A is guilty, A is going to be 11 and 72. A is going to be 83 people. If I look at B as did it, B is going to be 81 people. If I add 83 and 81, I've just counted the 72 twice. You with me on this? So this one subtraction gets rid of that double count, making sure we only count it 1 time. How many people were okay on that? Refresh your memory from last time. Good, all right, cool deal. Also, one other thing, this part gets confusing for a lot of people. When you're talking about the addition rule, you have this and up here. Now I'm going to preview some information. We are going to get another word and, the probability of A and B. It's going to mean something different than this and. I know that's confusing, but you have to look at the context of the formula. In this context, we are doing how many trials? 1 trial. So this and, in this context, means having A and B at the same time in the same trial. Does that make sense to you? Now, of course, that can't happen when you're rolling a die once. 1 and 5 are mutually exclusive events. You can't roll them at the same time. However, you can be both guilty and did it. That's right here, right? That's what we're talking about here. This and is the 2 events are happening at the same time during that single trial. You see, in the future, we're going to have just a standalone probability of A and B. And that's going to mean the probability of doing something and then doing something else. For example, what's the probability of rolling a 3 on the die and then in the next roll rolling a 5? Do you see the difference? There's 2 things. There's 2 successive events or 2 successive trials going on there. That would be out of 2 or more trials, and that's going to be the multiplication rule that you're going to see after our test on Monday. So the addition rule happens in a single trial, just 1 time, 1 roll of dice, 1 picking out of a person, just 1. This and in this context stands for still during a single trial. A and B occurring at the same time during a single trial. Okay. I also kind of threw out a definition at you just like 20 seconds ago or so. It's this word called disjoint. In statistics, the word disjoint doesn't mean like you have no joints. You're disjointed. No joints. That's not really what it means in statistics. What it means is that the events are mutually exclusive. It's really just another way to say mutually exclusive events. So when you're talking about disjoint events, you're talking about events which are mutually exclusive, or in other words, they cannot happen at the same time. That's what disjoint or mutually exclusive mean. They're kind of synonymous for the same thing. Disjoint means mutually exclusive. That's what we mean here. So if we have something that is disjoint, or I'll say it, disjoint events. Disjoint events are events which are mutually exclusive. They cannot happen at the same time. Cannot happen at the same time. That means during your single trial here. Let's see if you kind of get this. Let me give you a verbal example here. Is on one single roll of the dice, is rolling a 1 and a 5 mutually exclusive? Is rolling a 1 and a 5 disjoint? Okay. Can the 1 and the 5 happen at the same time? No. Then they are disjoint. Okay. How about this one? You have a deck of cards. You pull out one card. Is getting a heart and getting a diamond disjoint? You answer this question by, can a heart and a diamond happen at the same time when you pull out one card in your single trial? Then yeah, these things are definitely disjoint. They can't happen at the same time, they are disjoint. How about selecting someone in this class who is female and blonde? Is that disjoint? No, there are blonde females, right? You can pick someone out who is both blonde and female. How about in this example, is not guilty and did it? Not guilty and did it. Are those things mutually exclusive? Are they disjoint or not? No, you can actually get someone who is both not guilty but actually did it. There was 9 people who that was. Are you seeing the definition of disjoint play out for you? Disjoint just means that it cannot happen in the same roll of die or pick of the card or the same trial. Non-disjoint means that it can. So like our example with the blonde females or the not guilty and did it's. We can show this, maybe you've seen this before, this is called a Venn diagram. And I heard from someone that Venn diagrams aren't really even taught if you don't take statistics class anymore. So I have to teach you this because you're going to see this in a lot of places. Have you ever seen a Venn diagram before? Do you know what I'm talking about? How many people don't know what I'm talking about Venn diagram? It's fine if you don't. It's very easy. It's not a hard thing. Okay, good. So Venn diagram. Here's what this looks like. Get yourself a box right there. And inside this box we're going to put circles. Those circles are going to represent our sets of data.